Okay, here is my layout of what I think the Redrup cam profile for the valves looks like. And here we're looking at the followers, the three followers, and I haven't managed to get them to follow the cam profile in SolidWorks yet, but never mind. I haven't done the profiles particularly well. You can see here that they sort of match. They're just a set of arcs and straight lines. And but they're good enough for us to get the idea of what the profiles are going to look like roughly. These orange things are the 9 pins. This thing here is the rotor, the cam rotor itself, and this is the eccentric. Okay, let's have a bit of a look at how the valves work on this. We're here at 0 degrees and the bottom valve is open. So we'll wind around through 240 degrees and we notice that's missed. We get round to 240 degrees here and this valve's now open, so it's skipped that one. Okay, let's wind it round another 240 degrees to 480 degrees rotation of the crankshaft, and you notice it skipped this one and it's now sitting on this one. And one more time, another 240 degrees, and we're back down here and we're on this valve here and we skip that one. So you can see that it's back essentially where it started. Notice the one's up here now instead of being there, but because they're 4 lobes, we're more or less going to start the cycle again. In this video what I've done is I've put a mate between this arc here and this arc here, just a tangential mate. Not great, but it works just in this zone. Now I'll wiggle the eccentric on the crankshaft back and forward, and what you can see is that a large part of the opening action is actually the eccentric rather than the cam lobe, forcing the thing up till it gets up to this position up top dead centre here, in which case it's going a little bit wrong because this radius is coming around here. Okay, so the other thing that's wrong about this is that somewhere there on that line there, this particular line here, there's a stop of this follower, which would make that mate disengage. So the movement down below there is wrong. Suddenly the cam comes up and clobbers, this cam's coming up radially and it clobbers the follower, I think. There is a second way to visualize the rotor and follower movement. In SolidWorks I've mated the crankshaft and the rotor with a gear mate of 8:1 ratio, and you'll note that the rotor rotates in the reverse direction to the camshaft. So we'll go through the same movements again. We'll go around here 240 degrees to there, and you'll notice that it's gone from this follower around to this follower. We do the next 240 degrees around to 480 degrees, and you'll notice we've shifted from this follower across to this follower. And the final one from 480 to 720 degrees, and now we've moved from that follower to this follower. So it might be easy to visualize it that way, that the firing is not missing any, but it's going backwards, and you get a 360 degree firing for 720 degrees of the crankshaft in the opposite direction.